If it tells me use a calculator to determine to 4 decimal points the coordinates of a point on the unit circle that corresponds to a rotation of 148 degrees, this one is going to wind up being rounded, but we know that on the unit circle, x and y translate to cos of my angle, which in this case is 148 degrees, and sine of my angle, which is 148 degrees. So if I put cos 148 into my calculator, I get negative 0.8480. When I put sine of 140 in my calculator, I get 0.5299. And that is the coordinates of what it would be on the unit circle. At the same rate, it says the point of negative 0.8829 and 0.4695 lies on the unit circle. Determine the value of theta, where theta is the angle made by the positive x-axis and passing through t. That's a fancy way of saying it's an angle in standard position. So I can see that my x value is negative, my y value is positive. It's going to end up being somewhere in here. My rotation is going to be somewhere between somewhere between 90 and 180 degrees in quadrant 2. And then I can solve my reference angle one of two ways. I can solve my reference angle by taking the positive value of cos and saying if I take cos to the negative 1 of positive 0.8829, or using my y value, sine to the negative 1 of positive 0.4695. Remember, reference angles are always built on the positive versions. Either way, my reference angle to the nearest whole degree is 28 degrees. If that's true, then my rotation angle is going to be 180 minus 28. My rotation angle is going to be 152 degrees to the nearest whole degree. I can also combine the idea of the exact values along with the mathematical process in order to solve these. So if it says use the chart or unit circle to find the exact value of cos of 300 degrees plus sine of 330 degrees, I'd go to my unit circle and say that cos of 300 is positive 1 over 2. Sine of 330 is negative 1 over 2. Positive 1 over 2 and negative 1 over 2 is going to cancel out to make 0. And if I'm not sure, I can always double check on my calculator and put in cos 300 plus sine 330, and I should get 0. Now, whenever it has a superscript of squared, it means that I'm taking what the exact value of that ratio is and I'm squaring it. So if it says sine of 225 squared plus cos of 225 squared, what that actually means is take what the exact value of sine of 225 is, or negative root 2 over 2, and square it. Take what cos of 225 is, which also happens to be negative root 2 over 2, and square it. And this is going to give me, when I square the first one, root 2 squared is 2, 2 squared is 4, and when I square it, it should eliminate that negative. I'm doing the exact same process to the next one, which would also be 2 over 4. This is going to give me 4 over 4, or just 1. And once again, I can plug this into my calculator to verify it. The only thing is when I'm putting this in my calculator, what I'm writing in my calculator is bracket sine of 225 squared plus bracket cos of 225 squared. Your calculators probably don't have the sine squared or cos squared options on them. When I get to my last one, the process is still the same. If it's saying 2 times tan of 150 divided by 1 minus tan of 150 squared. Well, the nice thing is, in all these cases, all I need to find is what tan of 150 is. So I'm going to say that it's going to be 2 times negative root 3 over 3 divided by 1 minus negative root 3 over 3 squared. Two times negative root 3 over 3 is going to be negative 2 root 3 over 3. And I'm dividing that by 1 minus root 3 over 3 squared. And when I square it, it's going to eliminate that negative. And it's going to give me 3 over 9. Or if I just plug it in my calculator, root 3 over 3 squared is going to be the same as 1 over 3. So what I have is negative 2 root 3 over 3 multiplied by the reciprocal of this solution, is going to be 3 over 2, because 1 minus 1 over 3 is going to be 2 over 3. I can cancel out, just like we did in our rational expressions. And my final answer is just negative square root of 3. And that's it.